Hi guys, so today what we're going to do is we're going to be moving on to Chapter 7. Chapter 7, the first part, is probably a review for you guys as it focuses on factors and greatest common factors. But for today, what you guys need to first worry about doing is completing the entrance ticket that is posted for you. This needs to be done by 12 p.m. tomorrow. You also need to continue to watch this video lesson to guide you through 7-1. Your notes are posted on Schoology so that you guys can print them out and follow along, or you can take digital notes, whatever you're most comfortable with. And then finally, there is an assignment for you to complete at the end of the PowerPoint, and make sure that you submit your answers by 11:59 on Schoology. So, going through the lesson today, what you guys are going to be able to do is write the prime factorization of numbers and then find the GCF of monomials. So remember, monomials are just like single terms. So it's like x, 5, 3x, 2x squared. Okay, those are all example of monomials. And remember, GCF stands for greatest common factor. So we're going to find the greatest common factor of our monomials. Some new vocab words for you guys: prime factorization, greatest common factor, that is also GCF. Okay, so going through it, the whole numbers that are multiplied to find a product are called factors of that product. A number is divisible by its factors. So for example, like if I give you 6, its factors are 2 and 3. Okay, they're the two numbers that would give you the product of 6. You can use the factors of a number to write the number as a product. So exactly like I did with 6 up there. The number 12 can be factored several ways. So think about the different multiplication facts that you know that give you 12 as your product. So let's list them. So the first one, you could have 1 times 12. That's probably the most basic one. Then if I just go down the list, so if I'm starting with 1 and then I go, okay, 2, does 2 go into 12? And the answer is yes. So you can take 2 times 6. That's still going to give you a product of 12. Going down the list, 3. Well, I know 3 goes into 12 4 times. Okay. So they're probably the most basic ones for you guys. Now, when you are doing products, there's other ways of being able to do it too, and that's being able to break down your numbers even further. So if I just think about it with this first one here, I know I can break 12 down further by saying it into another way, which would simply be 1 times 4 times 3. Because if I think about it, I still have the 1 from over there first. And then the 12, I know 12 can be multiplied by 4 and 3, or 12 can't be multiplied by it, but the product of 4 and 3 does give me 12 again. And then I can also take this one right here and break it down a little further to be 3 times 2 times 2. Okay? And that one actually goes for the 2 times 6 as well, because it would give you the same exact product. So when that happens, they're giving you the factorizations, and there's multiple ways. Now, what that is called, when I were to break it down further, is prime factorization. So the order of factors does not change the product, but there's only one of the examples from before that cannot be factored any further, okay? And that one is when it's called prime factorization, because all of your factors are prime numbers. So if I just list them again for us, only one of these is factored all the way, and that would be this last one here of 2 times 2 times 3, okay? Because all of your numbers are prime. Now, if you don't remember what prime numbers are, I suggest that you Google it so that you guys know what prime numbers are, okay? Remember, prime numbers are any number where it's just 1 times itself will give you that number. The prime factors can be written in any order, and except for changes in the order, there's only one way to write the prime factorization of a number, okay? So I could also say this as being as 2 times 3 times 2. Or I could also say it as being 3 times 2 times 2. They're all going to give me the same product of 12. Again, multiplication is a commutative property, meaning I can change the order. All of these other ones, they all have a number that can be broken down further. Like 12, I can go to 4 and 3. But I can also go 4 to 2 and 2. 6, I can break down further to 2 and 3. 4, I can break down further to 2 and 2. And the same with this 4, I can break down further. Okay? So they're all being able to be broken down further, whereas 2 times 3 times 2, none of them can be broken down further. So remember, a prime number has exactly 2 factors, itself and 1. The number 1 is not prime because it only has 1 factor. Okay? So 1 is not considered a prime number. So let's go about doing these. So writing prime factorizations. There's 2 methods of being able to do it. The first method, factor tree, is probably the one that you guys are all most familiar with. But in order to do a factor tree and find the prime factorization of 98, you first start out with 98 up top. And then you just can start out by giving yourself a factor factors of 98. So in order to do that, I sometimes just start real small. So I'm not going to worry about 1 because then you're just having 1 and 98 and there's really no sense to use that 1. So I'm going to think to myself, can 2 go into 98? And the answer is yes. So factor tree, you branch it out and now you would have 2 times, and it's 49 that gives you 98. Well, 2 is a prime number, so I'm going to circle it because I know I can't break it down any further. 49, however, I can break down further. So if I think about it, what 2 numbers when multiplied together give me 49? So if you're saying 7 to yourself, you are correct. So I'm going to do 7 times 7. Well, when I check with myself, I realize 7 and 7 are both prime, so I'm going to circle them. So that means for 98, the prime factorization is equal to 2 times 7 times 7. Or if you really want to get fancy, you could write it out as 98 is equal to 2 times 7 squared. Both of them are going to mean the same thing, but that would represent the prime factorization of 98. Now, the second method that we're going to talk about is the ladder diagram. So in order to do this, what you do is you take 98 and you kind of put it like in a little box. And then you take the number and you're going to write it outside the box. So you're going to put it right there. So I'm going to use the same factors of 2 and 49. So I'm going to pull out the 2. So it's like saying it's like an upside down division bar, but 98 divided by 2 gives me 49. So I'm going to draw another ladder, and my 49 goes in here now. And then I'm going to ask myself, okay, so like what is a number that I can take out of 49? Well, I can take 7 out of 49. And when I do so, I'm left with 7 still, okay? So whatever you're left with goes inside the little house. Now, what is like a factor of 7 here? You know you can take out 7 again, but now when you take 7 out of 7, you're left with 1. So you're always looking to get this remainder of 1 when you're doing the diagram, okay? So with the ladder diagram, you're always looking for that last box to be 1. These numbers out here now represent your prime factorizations. So you still end up getting 98 is equal to 2 times 7 times 7. And that's the ladder diagram. You guys can pick any method that you want. I honestly think that the factor tree is a little easier, plus it's something you guys are most familiar with. So that's the method I choose to do. But again, you guys can pick whatever method you want to do. So right now, what I'm going to have you guys do is there's 4 you-try problems for you guys to try. Pause the video right now and give them a shot. So here's the answers for the first you-try. And here's the answers to the second you-tries. All right, and if you guys notice, my final answers I'm writing out as the number and then what it is as the prime factorization. So the next thing that we're going to get into is talking about greatest common factors. So factors that are shared by two or more whole numbers are called common factors. The greatest of these common factors is called the greatest common factor, or GCF. So you're looking for factors that are shared, so where they have the same number, but you want to now take the one that is the largest, because that's your greatest common factor. So we're going to start out with two numbers of 12 and 32, and we're just going to list our factors of these numbers. So remember, factors is when you multiply with the numbers, what are those two numbers that you are multiplying? So we did the factorization of 12 earlier, so just the factors of 12. So you have 1 and 12. And it's nice to list them in numerical order. It kind of helps you out that way. So I'm just going to kind of like put 12 all the way out here for now. And then you have 2 and 6. And then you have 3 and 4. Okay, and then you don't have any factors in the mix there. So now I'm going to move on to listing my factors of 32. So I have 1 and 32. Then I have 2 times 16. And then I have 4 and 8. So when I think about it, there's no other factors of 32. So now what we're going to do is we're going to identify these common factors that they have. So it's where they have the same numbers. So the common factors, looking at the 2 here, I see that they both have 1s. I see that they both have a 2. I see that only 12 has 3, but I see that they both have 4. And then they don't share any other numbers. So just the common factors are 1, 2, and 4. So now identifying what the greatest of those common factors is, it's going to be the highest number. So in this case, the greatest common factor is going to be 4. So when you're trying to find the greatest common factor, it's important to list your factors of the number and then find the highest number that there is that they're going to share. So what we're going to do is we're going to find the GCF, or the greatest common factor, of a pair of numbers. So when we're doing it, what we want to do is we want to kind of list out our factors, okay? So I'm first just going to start out with 100. So you have 1 and 100. And then think about your other factors. You have 2 and 50. You have 4 and 25. And then you're going to have 5 and 20. And then last but not least, you have 10 times itself. So just 10 and 10. And then you're going to list your factors of 60. So you're going to go about the same concept. So you have 1 and 60. You have 2 and 30. You have 3 and 20. 4 and 15. 5 and 12. 6 and 10. So now what you're going to do is you're going to look to see where your greatest common factors are. Well, it's not going to be 100 or 60 because they're just with those specific numbers. So you're just going to look down your list. So 2, they both share, but that's not the greatest because if I notice, they both share 4. They're both sharing 5. And they're both sharing 10. And then going down the list otherwise, it's just 50 here, just 30 there, 25. This has 20. And then 100 has 20. So if I notice, my GCF for these two numbers is going to be 20. Okay, 20 is the greatest common factor for them both. So if you guys go over, now you guys are going to have 2 you-try problems, so I want you guys to find the greatest common factor for the 2 problems that are there for you guys. So pause the video right now and try the 2. And then for the last one, if you said 5 was your greatest common factor, you are correct. They both have a factor of 5 that helps to make up their numbers. So that is greatest common factor when just dealing with numbers. What we're going to be looking at now is moving into using our monomials. So you can also find GCFs of monomials, and that also is going to include now variables as being part of the GCF. So in order to find a GCF of monomials, what you guys are going to want to do is write the prime factorization of each coefficient, and then you're going to write all the powers of your variables as products. So what that means is if I say x cubed, that's the same thing as saying x times x times x. So that's writing a power as a product, okay? And then once you have that, you're going to be able to identify the common factors and identify what the greatest common factor is going to be. So let's look at an example. So you need to find the GCF of each pair of monomials. So first, just start out with one of your terms. So I'm going to first just start out with the 15x cubed, and I'm just going to write it out. So write out a factor of 15, which is 3 times 5, and then write your variable terms as a product. So you have x cubed, which means you have 3x terms. So you're just going to write them out. And then you're going to do the same thing with 9x squared. So you're going to write a factor of 9, which it's 1 and 9 or 3 and 3. So I'm just going to use 3 times 3. And then I'm going to write out x squared as being x times x because you have 2 of them. Now what you're going to do is you're going to circle the terms that they have in common. So I know they both have one set of 3's, and then they're both sharing these x terms right there, and then these ones they're also sharing. Now this top one has an additional x, but there's nothing down at the bottom for it to be shared with. So I can't say that is also a factor, okay? It has to have an equal number of x's in order to be factors. So with this being said now, your greatest common factor is going to be a product of these terms that I have circled. So that means you're going to have 3 times x, and I'm just going to write this in the simplified form, which is going to become my GCF of 3x squared. So it's important to write out your factors of your numbers and then write out the factors of your variables. Let's look at another one together. So you have 8x squared and 7y cubed. So I'm going to start out with 8x squared. So thinking about, I want the prime factorization of my number. Well, with 8, you can have 2 times 4. 4 is not prime yet, so I have to break that down into 2 and 2. Okay, so that means my prime factorization is 2 times 2 times 2. And then writing my variables out as factors, that now becomes x times x. And I'm going to do the same thing with 7y cubed. So 7 is just 7 and 1. So I have 1 times 7 here. And then I have y's of y times y times y. Now, if I notice, there's no terms that they're really sharing. However, could I add a 1 in right here and say 1 times 2 times 2 times 2 times x means 8x squared? The answer is yes. So in this case now, they're not always going to share a number that came from the prime factorization. Sometimes you might have to think a little bit basic in the sense is like, what's the number that they're going to share? So in this case, your greatest common factor is just going to be 1. There's no other term or variable that they're going to have as a greatest common factor. It's simply just going to be 1. And that's okay. Not all numbers are going to have greatest common factors. So one thing for you guys to know is if two terms contain the same variable raised to different powers, the GCF will contain that variable raised to the lower power. So like if I say 8 or x to the 5th and x to the 10th, your greatest common factor here would be x to the 5th because it's the lower power. If I said x cubed times x, it would just be an x in this case because x is raised to the first power, okay? You can only take as many x's out as the lowest term. Okay, so I'm going to have you guys try the 3 examples that are there for you. So pause the video right now and try the 3. So your first U-try problem, your answer is 9g squared. Your second U-try problem is 1. They're not sharing any other common factors other than 1. And then your last one is also 1. There's no other greatest common factors. So what we're going to do now is we're going to try some application problems. So getting started with this first one here. In the SLCS cafeteria, which all of you are missing so much, all of that wonderful food, there are 18 chocolate milk cartons and 24 regular milk cartons. The cook wants to arrange the cartons with the same number of cartons in each row. They're having a little bit of OCD today. Chocolate and regular milk will not be in the same row because you can't mix the two. How many rows will there be if the cook puts the greatest possible number of cartons in each row? So what we're going to do is we're just going to find our factors of each of our numbers. So I have to find my factors of 18 and I have to find my factors of 24. So take a moment and let's list them. So your factors of 18 are 1, 2, 3, 6, 9, and 18. And then your factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So the question is now is to find how many rows will there be if the cook puts the greatest possible number of cartons in each row. So that means I need the greatest common factor for my two numbers. So if I notice, both of them share a 6. So that's the greatest possible number of cartons that I can put in each row. So now I'm going to have to figure out how many rows I'm going to have. So if I take 18 and divide it by 6, that means I'm going to have 3 rows of chocolate. And then if I take 24 and divide it by 6, that means I'm going to have 4 rows of regular. So all in all, there's going to be 7 total rows of milk. So with these, it's just important to list out the greatest common factor of your two numbers, and then you take that greatest common factor out of your factor to figure out the total number. So I'm going to ask that you guys try this U-try problem, and then you'll be able to double check your work. So pause the video right now. All right, guys, there's the U-try problem for you guys dealing with the word problem with finding the greatest common factor. So I first listed the prime factor or the factors of 36, and then I listed the factors of 48. And then once I found the greatest common factor, I then did the division between the number and then the greatest common factor to figure out how many shelves I was going to need. And then I took the two, added it together to give me my final answer that she is going to need 7 shelves in her storage unit. So that's the end of lesson 1 for chapter 7. What you guys are going to have to do now is you guys have some book work to do. You need to complete the problems and then submit your answers on Schoology by 11:59. So if any of you have any questions, please reach out to me. Otherwise, guys, have a great day.